Good morning, students. Your teacher here again. We're starting again with this one-to-one relationship. Um, Again, we're going to define a constant of proportionality as 1x and 1y. 1x and 1y. All the x's and the y's lie on a single line, okay? And it goes to the origin right here. Okay, so is y equals 18x a constant of proportionality? Yes. You see that the equation y equals 18x passes through the origin. All the elements of x have a corresponding y. So yes, that is a constant of proportionality. What if y equals 0.001x. Well, sure, that is a constant of proportionality. You can't see it, but it'll eventually get, wow, that's really close to the line right there. You have to get out pretty far for it to even like get above the y. Yeah, that's crazy. I haven't seen that before. Well, I have. It's a bit shocking a little bit. Okay, so but that is a constant of proportionality. Okay, because it passes through the origin, it's got a constant of 0.001. What about when y equals negative 1? Is that a constant of proportionality? Yes. Yes. It's linear. It passes through the origin. Okay, it just so happens that the slope or the k is negative 1. What about when y equals what happens when y equals x squared? Okay, is it a linear? Yes, it passes through the origin. Yes, there's a one-to-one relationship. If you do the straight line test, okay, there's always going to be a unique corresponding x to a corresponding y. But is it linear? That is not a line. That is a parabola. We'll get through parabolas in algebra or algebra 2, depending on how fast your teacher is or how sharp he or she is. But that is a parabola. That's obviously not a line. Okay, there's lots of applications for parabola, not a line. So not a constant of proportionality per se. If that was a constant of proportionality, what would it be? It would be 1, but you see how x is times itself, so it performs this shape right here. What about when y is equal to x cubed? Okay, not a constant of proportionality. Yes, it passes through the origin, but it's not linear. Okay, the same is true for a logarithmic function, not a y. That doesn't even pass through the origin. So that fails on two scales. What about when we have y equals x plus 1? Okay, no, does not pass through the origin. It is linear, but it doesn't pass through the origin. What about when y equals x minus 1? Again, doesn't pass through the origin, is linear, it doesn't pass through the origin. Now let's just do a little excursion here. Okay, are those two parallel? Yes, they are parallel. They are parallel. Why are they parallel? They're parallel because they have the same slope. A little excursion there, not really what I wanted to talk to you today about, but that's, when you see something like that, you gotta take a note of it.